Hello everyone, my name is Aaryan and today we are here to discuss the Leetcode Weekly contest 425 which took place today. So the first two questions were pretty easy, so we are going to discuss the third and fourth question and majorly the fourth one because that wasn't the straightforward question and वो एक काफी interesting topic था that is DP on trees. So let's start with the third problem. So the third problem is, let's first give a read to this problem statement. So you are given an integer array nums and three integers k option 1 and option 2. So you can perform operations on nums like this, that operation 1, choose an index I and divide nums of I by 2. So let's quickly write down what is given to us. Cool. Cool. So basically we are given with an array. This is problem C. We are not discussing problem A and B today as I have a shortage of some time and they were pretty easy, though वो easily solvable है. So in problem C we are given with an array nums, cool, three variables k, operation 1 and operation. So for operation 1 and operation 2 we can perform these operations on the array like this, that if we choose to do operation 1 we can choose any index and divide that by 2 and rounding up the nearest whole number. So basically we are gonna take the seal of this while dividing. So you can perform this operation at most operation 1 times and not more than once per index. So basically if this is the array, so we can perform operation 1 on this index, but there is a condition that we can perform operation 1 at most once at any index and not more than once. Similarly, for operation 2, we can choose any index and subtract k from the nums of I value, but only if that nums of I is greater than or is equal to k. So if there is any value in the array that is greater than or is equal to k at the moment, तो हम उसमें से k subtract कर सकते हैं. So we can also perform this operation at most once per index. So both operations can be performed at the same index, but at most once each. So basically क्वेश्चन ये कह रहा है कि आप इस पे ऑपरेशन 2 भी परफॉर्म कर सकते हो एंड ऑपरेशन 1 भी एंड बोथ टुगेदर भी, कि दोनों तीनों पॉसिबिलिटीज अवेलेबल हैं हमारे पास. बट ऐसा नहीं है कि मैं फॉर एनी इंडेक्स मैं इस पे ऑपरेशन 2 परफॉर्म कर दूं एंड दोबारा से ऑपरेशन 2 परफॉर्म कर दूं. दिस इज नॉट अ वैलिड ऑपरेशन. So return the minimum possible sum of elements in nums after performing any number of operations. So let's see the first test case. 283913, 283913, and we are given k as 3, number of operations 1 available to us as 1, and number of operations 2 available to us as 1. So इसको हम operation 2 perform. Cool. So we can perform operation 2 on this. So this will be reduced by 3 and the new state will look like this, 13. And we can perform operation 1 on this. In that case it will be 2, 5, 3, 9 and 7. So the sum will be 7, 3, 10, 19, 21, 26. So is this minimum? No, 23. So we have to Okay, it's 19. Oh, test case गलत लिख लिया. Let's go back and correct our test case. Okay, let's write it down again. So it's 2, 8, 3, 19 and 30. Oh, not 13, it's 3. So value of k is 3, operation 1 is 1 and operation 2 is also 1. तो ये हमें clear है यार. In operation 1 any number can be reduced by half. Clear है. And in operation 2 we can subtract k. So more beneficial is obviously half until and unless k is a number which is big enough. तो हम सबसे बड़े नंबर को let's reduce it by operation 1. So it will be 10 in this case. Similarly, we can perform operation 2 on this same number also, but let's perform operation. Okay, let's perform operation 2 on this number itself. So it will be 7, 2, 8, 3, and 3. Cool. So the total sum is 7, 3, 10, 23. So the total sum is 23 for this particular test case, and we can see that yes, the total sum is 23. So even after just reading the problem statement, I hope this would be clear कि हम इस क्वेश्चन में क्या कर सकते हैं. And the idea could be, because we cannot greedily select that whether we should perform operation 1 on this or operation 1 on this, and similarly how can we just uh, tell that whether which operation has to be performed on which index, and हम किस पे मल्टीपल ऑपरेशंस परफॉर्म करें या किस पे ना करें, बिकॉज वी डोंट नो हाउ दिस array is gonna get reduced to some further states based on the current state. And secondly, if we just see the constraints, the length of the array is at most 100. So if, let's suppose this is our array with some values filled in it, so for any index, what are the total possibilities that I can have? फर्स्ट थिंग इज मैं इस पे ऑपरेशन 1 परफॉर्म कर दूं. सेकंड थिंग इज मैं इस पे ऑपरेशन 2 परफॉर्म कर देता हूं. थर्ड थिंग इज लेट्स परफॉर्म ऑपरेशन 1 एंड ऑपरेशन 2 both on this array index. Fourth option is don't perform any operation. So is there any other possibility for any particular index? I hope no, because these are the only possibilities that I can have for any index. So whenever I perform operation 1, so my count for operation 1 gets reduced. So for, if let's suppose I'm going to perform operation 1 on this index, so for this particular array I will be left, let's suppose there is some initial count of operation 1 as 2, so I will be left with one operation 1 count. So don't you think that for any index, if I try to check for all the possibilities, and if anyhow I can figure out that what will be the minimum cost, or sorry, minimum sum from this array after I perform any of these operations on any particular index, then I would be able to figure out that which option is best fit for me. So it's a clear TP question where instead of just two simple states, pick not pick, I have some options. So basically there are four options. And what are those four options? For any index, I have these options that perform operation 1 or perform operation 2, or I can perform both the operations together and don't perform, because there is a possibility that operation 1 plus 2 is less than n. So in that case, it is not compulsory to reduce every possible index or every possible number in the array. So there may be some indexes where we are not going to perform any operation, just like in the sample test case. So no operation. For any particular index, I can perform on these operations and see which one yields the minimum answer for me. So if this is my array and I'm standing at any index I with, let's say, operation 1 count as 2, operation 2 count as 3, let's say. So if I'm gonna perform operation 1 on this index, then from I plus 1, I am left with operation 1 as 1 and operation 2 as 3. Cool. Similarly, if I am gonna perform operation 2 on this index from I plus 1th index, my operation 1 count will be same, but my operation 2 count will be reduced by 1 because one operation is utilized here. Similarly, if I'm gonna use both the operations here, then for I plus 1, my operation 1 will be 1 and operation 2 will be 2. Cool. But what if we don't perform any operation? No operation. In that case, we will move to the next index with same number of operations in our hand. So that's how we can compute the answer for any particular index. And once we reach to the end of the array or any of the operations are over, not any, all operations are over. In both of the cases, we can just return from here. So basically, we are gonna use a function f with index, count of operation 1 and count of operation 2. So for each of the following states, we can get the answer from further state. So this is the option 1. So we are going to take care of the condition also, because for performing operation 2, the element should have a value greater than or equal to k. So that should have been kept in mind. And there is one more thing which we should consider. So in this case, we are going to reduce our operations 1 count. In this case, we are going to reduce our operation 2 count. In this particular case, we are going to reduce our operation 1 count as well as operation 2 count, and this is going to be the same with the next index. Cool. But for this particular test case, there is some speciality. What's that? So basically we are gonna perform operation 1 and operation 2 simultaneously on same index. So there can be a possibility that first we are going to perform operation 1, that is divide the number by 2, and it will be a sealed divide, make sure. Second thing is to perform operation 2 and subtract the value by k. Similarly, what we can do is firstly perform operation 2 and then perform operation 1, which is divide by 2. So the order of these operations can make the value differ. How? So let's suppose the value is 19 and our k is let's say 3. So the first, if we go with this way that perform operation 1 first and then 2, so after performing operation 1 it will be 10, and after performing operation 2 it will be 10 minus 3, 7. Similarly, if we perform operation 2 first, it will be 16, and if now we perform operation 1, it will be 8. So the order of these operations are also gonna make the difference. So make sure to choose the minimum of both of these uh, sequences. So this was the case which might have uh, created some issue with some of the codes. So think of this. So basically we have these three states in our function, I operation 1 and operation 2. So for this we can make a 3D DP to memorize our function, and the scope of index is 1, so make sure it's larger than this. So basically the size of the array was 100, so that's why we are going to take some extra positions. Similarly, operations 1 and operations 2 both will be less than or is equal to the size of the array, so they can also go up to this much size. So that's why we are going to make the array of at least this size or greater than that. Similarly, this is the function that we just defined with three variables, I option 1 and option 2. So if we reach to the last position, we are gonna and return from here with 0, and for any other state if we have the answer computed, we are going to return it because we are memoizing our function, and this is the answer for this particular state, and we are storing the original number in a variable. Why? Because if we just perform the operations on the array itself, the dividing operation or subtracting operation from, with k, so that's going to change the original state of the number. So that's why storing and using that variable is a better idea. So the first option is don't do any operation. In that case, we know our answer is going to come from this state, and the sum for this particular index will contribute the value that will contribute to the total sum will be the original value. Similarly, if we do operation 1, so in that case operation 1 should be greater than 0, and we are going to divide. So this divide function is nothing but a shield divide by incrementing a odd value to a even and then going to divide it. Similarly, we are going to perform operation 2, and we are also checking the condition to perform operation 2 that it should be greater than and is equal to k. Similarly, if we are going to perform operation 1 and 2 both, so in that case there could be two values, value 1 and value 2. Value 1 is basically performing operation 1 first and then 2, and similarly value 2 is performing operation 2 first and then operation 1. So the final value is the minimum of both of them, and similarly we are going to compute the answer from the further states with decrementing both operation 1 and operation 2 in the function call. So this is just memoizing the function, and this is initializing the dp array with -1 values, and that's how we are going to return the answer from our function. So I hope you understood this problem statement, the idea behind solving it. So let's now move on to the next problem, and ये काफी अच्छा problem था यार. I got plenty of wrong submissions in it, and उसके बाद जाके accept हुआ था, and I will be discussing that how I approached this problem initially. Initially मेरे mind में क्या था, how I wrote some initial solution, वो क्यों fail हुए, and then how I got to know that ये एक DP or we can say DP on trees based problem है. So let's start reading the problem statement that there exists an undirected tree that okay. So firstly let's talk about tree and undirected tree. So this is problem D. Cool. So basically the main difference between tree and graph is that there will be edges in both of them, there will be nodes in both of them, but the major and essential difference is that in the tree there won't be any cycle, any kind of any cycle, and in the graph there may be some cycles. So to adhere this property that there should not be any cycle, every tree has at most n minus 1 edges, because if the tree has greater than n or is equal to n edges, in that case there will be cycle for sure. So this is the most important property of trees, that it has at most n minus 1 edges. And for directional edges, they are basically like this, that you can always go from A to B and can't go vice versa. But for undirectional edges, you can go from A to B and B to A simultaneously. So we are given an undirected tree with n nodes numbered from 0 to n minus 1, and you are given a 2D array edges of length n minus 1. So it's clearly mentioned here also, where edges of I will be in this form, which denotes that there is an edge between ui and vi with a weight wi, and indicates that there is an edge between nodes this with this. So your task is to remove 0 or more number of edges. So we can remove any edge or we cannot, and each node should have at most k other nodes. So basically, sorry, edge with at most k other nodes, and the sum of the weights of the remaining edges is maximized. So return the maximum possible sum of weights. So let's quickly make this diagram. So 0 is connected to 1 with weight 4. So if we try to understand the problem through the first sample, so 0 is connected to 1 with a weight 4. 0 is connected to 2 with a weight 2. Cool. 2 is connected to 3 with weight 12. 2 is connected to 3 with weight 12. And 2 is connected to 4 with weight 6. So this is the tree given in the first test case. So any node can have at most k edges. इससे ज़्यादा नहीं हो सकते. So in this case, k was I guess 2. Yes, k is 2. So हर node के पास दो edges हो सकते हैं. So we can say कि हर node के सिर्फ दो adjacent neighbors हो सकते हैं, इससे ज़्यादा नहीं. If हैं तो हमें वो edges remove करने हैं, and we have to remove edges in such a way that overall जो बाद में सारे weights का sum बनेगा of the tree वो maximize होना चाहिए. So if we try to see 0 कितने edges हैं, एक एंड दो. कूल है यार, दो होने चाहिए, दो हैं, दो से कम चलेंगे. ऐसा नहीं है कि दो ही होने चाहिए, दो से कम चलेंगे, बट कैन नॉट बी मोर देन 2. कूल. 1 के लिए देखते हैं. 1 के लिए तो यार एक सिंगल एज है, नो इश्यूज, कैरी ऑन. फॉर 2 वी सी आर कितने एजेस हैं, एक दो एंड तीन. तीन एजेस हैं, क्लियर है. बट तीन नहीं होने चाहिए यार, वी कैन हैव एट मोस्ट 2 एजेस. इसमें से हम किसको हटाएं सो दैट द ओवरऑल सम एट द एंड विल बी मैक्सिमाइज्ड. देयर आर 3 एजेस, हम तीनों में से किसी को हटा सकते हैं. इसे भी, इसे भी, इसे भी. किसको हटा के मुझे एंड में मैक्सिमम सम मिलने वाला है? क्या 12 को हटा के मुझे एंड में मैक्सिमम सम मिल सकता है वेट्स का? नो, पॉसिबल ही नहीं है. वी हैव टू रिमूव द edge which is carrying the minimum weight, because that's how we can compute the maximum answer at the end. Cool. Let's remove this edge as of now. इसके बाद k के बाद सॉरी 2 के पास कितने edges या adjacent nodes बचे हैं? दो. Cool. It's acceptable. Similarly 3 के पास कितने हैं? एक ही है. 4 के पास कितना है? एक ही है. कोई इशू ही नहीं है. टोटल वेट कितना आ गया? 4 plus 6 plus 12, which is 6 10 22. So is 22 the answer? Yes. Cool. दूसरा टेस्ट केस देखते हैं यार. 0 is connected to 1 with weight 5. So 0 is connected to 1 with weight 5. 1 is connected to 2 with weight 10. 1 is connected to 2 with weight 10. 0 is connected to 3 with weight 15. 0 is connected to 3 with weight 15. 3 is connected to 4 with 20, 3 is connected to 4 with 20, and 3 is connected to 5 with weight 5, 3 is connected to 5 with weight 5. एक सेकंड इसको इरेज कर देते हैं, ये 1 कुछ भी नहीं है, ठीक है. Now 0 is connected to 6 with weight 10, so 6 with weight 10. Clear है. K is 3 in this case. So अब कोई भी node can have at most 3 edges or 3 neighbors. Cool. Let's check किसी के पास ज़्यादा तो नहीं है. 0 के पास 1 2 3, no issues. 1 के पास एक ही है, 2 के पास एक ही है, 6 के पास एक ही है. This 3 is gonna have 1 2 3. Cool. तो इसमें यार सबके पास ही 3 3 है, not more than 3. तो हम सारे weights को कंसीडर कर सकते हैं. So in this case it's nothing but the total sum 10 and this 15, this 5, this 20. I hope सब कुछ सही लिखा है. So 25 30 40 50 65. So yes, 65 was the answer for this test case. Cool. तो यार अब हमें ये समझ में आ रहा है कि for any node अगर उसके पास number of adjacent edges या nodes या number of childs ज़्यादा है, greater than k है, तो हमें कुछ हटाने पड़ेंगे. If let's say number of नीचे लिख लेते हैं. So if number of childs of any node is greater than k, so we have to remove them. And इनिशियली अभी हमने टेस्ट केसेस जो देखे या हमें आइडिया आया, तो होना क्या चाहिए, हम किसको हटाएंगे, विद मिनिमम वेट, है ना. दिस शुड बी, बट हम कांस्टेंट टाइम में कैसे हटा सकते हैं. बट एक इशू और भी होगा कि यार लेट्स सपोज हमें अगर हम ट्री बनाते हैं जनरली, सो इफ देयर इज एन एज बिटवीन 0 and 2, तो हम क्या डालते हैं यार, adjacency of u contains v, similarly adjacency of v contains u also, vice versa हम दोनों कंडीशंस डालते हैं. सो इफ फॉर 2 आई एम गोना रिमूव 0, मुझे 0 के लिए भी 2 वाला एज रिमूव करना पड़ेगा. so this can be easily done using a set. यार फॉर एवरी नोड इंस्टेड ऑफ स्टोरिंग वेक्टर्स आप सेट स्टोर कर लो which will store weight comma v, I would say, and this is set for a node u. So we can easily erase and search in this. But हुआ क्या, once I submitted the code with this approach, I guess मेरे पास है इसका टेस्ट केस, I got wrong submission and काफ़ी ज़्यादा wrong submissions हैं, यहाँ देख सकते हो आप. So for this test case I got wrong answer and काफ़ी सारे similar test cases पे आया था ये. So if we try to see the test case, क्या test case है, so 0 is connected to 3 with weight 2, so 0 is connected to 3 with weight 2, 0 is connected to 2 with weight 39, 0 is connected to 2 with weight 39, and 2 is connected to 1 with 29. So 2 is connected to 1 with weight 29. Cool. So k can be 1. So k can, so k is 1. So any node can have at most one adjacent node or one adjacent edge. So let's see क्या कर सकते हैं हम इसमें. एंड इसके अलावा एक और टेस्ट केस था, सी की कौन सा था, या आई गेस मुझे याद है. ओके, सो बेसिकली इसमें क्या था, इफ वी सी फॉर 0, हमारे पास क्या क्या ऑप्शंस है कि हम मिनिमम वाला हटा दें, लेट्स रिमूव दिस मिनिमम वन. एंड फॉर 2 इफ वी रिमूव दिस, so the ideal answer should be 39. So this is not the test case I was looking for. So basically कुछ ऐसा था यार कि there was, okay मेरे पास कॉपी में है. Cool. Yes, 0 was connected to 2 with weight 10, 0 was connected to 1 with weight 25. This was connected to this with weight 3 with weight 29. Yeah, this was the test case. And K was, I guess, 1. Yes, yes, yes. Cool. K1 tha. So in this test case, if we go with our initial approach that 0 is having more number of edges, so remove the one with the minimum weight. हम 10 को remove कर देंगे. Similarly, if we go to this one and we will see कि यार minimum कौन सा है इसका, इसके पास भी ज़्यादा edges हैं. Minimum कौन सा है? This one. Remove it. So what is the total sum we got? 29. But if instead of removing the minimum weight of 0 to achieve one edge, we can remove this edge, because after removing this edge it will solve the problem for the 1th node and the 0th node, and the total sum in this case achievable is 39. This was a test case where I got the wrong answer and got to know कि यार ये problem greedily solve नहीं हो सकती, and for any node there might be a possibility that even after removing the node with the maximum weight, I got the total sum of the tree as maximum as compared to removing the edge with the minimum weight like this. So once I got the idea that this is not going to be solved with a greedy approach and we should think something better. So वहाँ कुछ idea hit हुआ, something like this कि for this 0, this is 2, 10, 1, 25, 3, 29. Cool. So for any node there, if the total size, so basically for any node, if the total size of, let's particularly make the adjacency of this. If I'm gonna make adjacency of 0, it will gonna store the information related to 1 and 2. Similarly, 1 is gonna store the information related to 0 and 3, and so on. 2 will store information about 0 and 3 will store information about 1. Cool. So for any node I got to know that the total number of edges are more than k or not by just looking at the size of this adjacency. That's yes, it is greater than is equal to k because k was 1 in this. So if any node is gonna have greater number of edges, हमें कुछ remove करना है. So what if I remove this edge? In that case होगा क्या? For this one, ये parent वाला edge consider नहीं होगा. Parent edge नहीं कंसिडर होगा. उस केस में इस वन के पास कितने एजेस बचे हैं? दो जो इनिशियल थे, उसके बाद उसको में से एक एज तो मैंने कम कर ही दिया. अब उसको बाकी इनिशियल में से -1 वालों को अकोमोडेट करना है और चेक करना है कि यार अब क्या वो लेस देन इज इक्वल टू के हैं या नहीं. सिमिलरली देयर इज अ पॉसिबिलिटी दैट मैं इस पेरेंट एज को कंसीडर करता हूँ. इफ आई एम कंसीडरिंग दिस पेरेंट एज, तो जो के एजेस रखने थे मेरे को उसमें से एक एज तो मैंने फिक्स कर दिया विच इज दिस पेरेंट एज. बाकी बचे हुए कितने? की -1 एजेस के लिए उस पर्टिकुलर चाइल्ड नोड को कुछ आंसर कंप्यूट करना पड़ेगा. सो वंस आई गॉट इनटू दिस अप्रोच, तब मुझे थोड़ा सा रियलाइज हुआ कि यार यस वी कैन स्टोर अ स्टेट और a DP based solution of this tree, something like this. Key let's 2 3. So I'm not gonna write the total weights here. Let's assume it to be w1 w2. Okay, so अगर हम for this 0th node कुछ काम करना चाह रहे हैं, so in that case for this edge I have two choices. What are these two choices? That should I take this weight into my consideration or should I not? So for those two choices, if we take this weight, so in that case, what are we expecting from one? If we are gonna take this weight, तो हमें W1 weight तो मिल गया. We got this into our answer, and we are expecting from one कि यार वन को कितने टोटल एजेस रखने की अलाउंस थी के. बट यार एक एज तो मैंने ऑटोमेटिकली फिक्स कर दिया. सो भाई वी आर एक्सपेक्टिंग कि वन से कि यार फ्रॉम के माइनस वन एजेस एक्सक्लूडिंग पेरेंट वन, क्योंकि ये तो फॉर श्योर एक थिंकेबल थिंग है कि यार इसको हम अगर अकोमोडेशन में ले रहे हैं तो चाइल्ड को उससे कोई लेना देना नहीं है. सो के माइनस वन एजेस एक्सक्लूडिंग पेरेंट वन, मैक्स आंसर लिया. अगर वन ये हमें ला के देता है, सो वी नो दिस W1 and this max answer is a valid answer for zeroth node. Similarly, if we go for option 2 from this zeroth node that not take this edge, so in that case we are gonna lose this W1 weight. Cool. But हम वन से क्या एक्सपेक्ट कर रहे हैं? एक्सपेक्टिंग फ्रॉम वन दैट के एजेस आपने देखने हैं एंड उसका मुझे मैक्स आंसर ले आओ and I'm gonna use it. So this was the main idea behind solving this problem कि यार हम for any node और उसके सब चाइल्ड वाले नोड्स के बीच में जो वेट है उसको क्या मैं लूँ क्या मैं नहीं लूँ. इफ आई एम गोना टेक इट तो बाकी जो चाइल्ड है उसके पास सिर्फ के माइनस वन एजेस की रिस्पॉन्सिबिलिटी होगी. एंड व्हाट इफ आई नॉट टेक दिस एज, सो इन दैट केस जो भी हमारा चाइल्ड नोड है उसके पास जो रिस्पॉन्सिबिलिटी होगी दैट विल बी फॉर के एजेस, बिकॉज अभी तक कोई भी एज फॉर दैट चाइल्ड नोड अकोमोडेशन में नहीं आया है. सो इसके लिए माय आइडिया वाज फॉर every node I am gonna store two states, something like this. For every node there will be two DP states. And what are those two DP states? They are like mm, so DP of, let's, yes, DP of child 0 and DP of child 1. And ये क्या डिनोट करने वाली है? 1. ये डिनोट करेंगे कि यार DP of child 0 will denote the max answer for subtree rooted at 0 when parent edge is not considered. Cool. Similarly, DP child 1 denote करेगा कि यार max answer. Similarly for subtree rooted at not 0, subtree rooted at child. So when parent edge is taken. Cool है. So once I know for, let's suppose if we consider the same tree, so for this one, this is basically the edge between this is our child node for now, this is our parent. So for this child parent relation we know this is the edge between child and parent. and we are gonna make two choices whether to take it or not. So if we are gonna take it, we know we are gonna get W. Similarly, this child is gonna have two states, dp of this child 0 and dp of this child 1. So these states should be computed before we are gonna compute the solution for this 0th node. So we know that we should go to the bottom and compute the answers upwards, so that for any node we already have the answer computed for its childs. So for this is the answer when the parent edge is not considered. So when we are gonna taking it, so in that case we will be taking this value, which is the maximum answer in the subtree rooted at child when the parent edge is not taken. Similarly, when taken. So for not taking part, we know the answer would be simply dp of child 0, because we are not taking this edge. So this tree has whole soul the right to take k edges of his choices in its subtree. Cool. So this is the basic idea behind solving this problem. So the second issue that I got into was here for any let's suppose node. Let's not talk about 0 only. So for any node, there are, let's suppose, बहुत सारे different edges. So for any edge, I know that I can take this, not take this. But this take not take choice is available for too many nodes at any level. Sorry, too many childs at any level. So इसको कैसे gather करें हम? We should tackle this thing also. So for any edge, if this is the edge, हमारे जो दो possible options हैं वो कौन कौन से हैं? Option 1 is W plus dp of child 1, and option 2 is directly dp of child 0. So to tackle this situation and thing, I had taken the delta between them, because delta is nothing but the difference between my option 1 minus option 2. So if this delta is maximum, so let's suppose this delta is 0 for this, 1 for this, 2 for this, 4 for this, 5 for this. So in any case, if that delta is more, so option 1 is yielding more for me. So in that case, I'm gonna take this edge and leaving some edges that are not giving me some creator positive delta. और जो नोड मेरे को छोटा डेल्टा दे रहा, तो इन दैट केस तो मुझे प्रीटी श्योर है कि मैं उसको लूंगा ही नहीं. आई एम गोना गो विद द option 2 choice for that particular node. So I am gonna take the maximum deltas in this condition. So इस वजह से मेरे को मिल जाएगा कि यार my I will only because I can have at most k edges किसी भी position पे. And what if there are total 2k options? So I can only take half of them. But कौन से वालों को मैं लूँ? These are the edges जो मुझे maximum profit yield करके दे रहे हैं, maximum delta दे रहे हैं. So I'm gonna take them and I will ignore all of these, because losing them is pretty much straightforward deal of more profitable solutions. So I'm gonna lose them. So are we gonna compute this delta? So just put these values here. So this is nothing but dp of child 1 minus dp of child 0. So that's how we can compute the delta at every level, and we are gonna take k max deltas into our consideration. So and for both the cases, for 0th and 1th, dp value in this case we are going to take exactly k, and this case we are going to take k minus 1 deltas. So that's how we are going to compute the solution at every level. So if we see the code for this, so let's have a dry run first, because this is not something very intuitive for a person who is not much into trees and graphs. Visualize how this solution is gonna work. Cool. So let's start from this node. So let's say we have answer computed for every of these leaf nodes already. So for this node, if my k is equal to 2, so we are not gonna take, consider, or think of this particular node. Let's avoid this for now. So we are only gonna make sure that this particular subtree has its answer computed. Cool. So let's think how we are gonna do this. For k is equal to 2, we know I cannot have all of these three edges. I can only have at most these two. Cool. So for this node, I have to compute two values, which is dp of 0 and dp of. So dp of 0 denotes that I am not gonna take the parent edge, so I can take k edges, and this is the way that I can only take k minus 1 edges. So which is the, if I compute k minus 1, it is 1. So which one of these three edges should I take so that this value is maximized? So how I can say that which edge should I take, because I cannot know how which edge gonna yield me the best possible answer. So what I'm gonna do, I will calculate delta. Delta will be nothing but weight plus dp 1th value minus dp 0th value for every of this child, and let's try to sort them in array. हमने इन सबको एक array में store करा लिया, and once we sort it out with uh, decreasing order, we know the maximum values are present at starting. So मैं starting k minus 1 max values को अपने consideration में ले सकता हूँ. But how are gonna this help, how this thing gonna help me in my total solution? So I know if I take k minus 1 edges, what do I need to get? dp1, these max values plus dp of 0 remaining values. Or let me explain this more clearly. Let's suppose we have k is equal to 3 and total number of available nodes are 8. Cool. तो इसमें से मैं 3 ही edges ले सकता हूँ, बाकी 8 मुझे edges, sorry 5 edges drop करने पड़ेंगे. So if this is the condition that total there are 8 childs, so let's suppose मैंने ये 3 edges ले लिए. For these 3 edges I'm gonna take w1 plus dp 1th value of this first child, w2 plus dp 1th value of this second child, w3 plus dp 1th value of this third child. But for the remaining childs, I am gonna only take dp 0th value of those childs. So if I sum up all of dp 0th values for all of these childs, so sum dp 0th values, and whenever I take any gain, my gain is gonna have dp1 minus dp 0th value. So this is the basically the gain for any particular node, or I can say the delta for any particular node. So if this delta is positive, so this is gonna be beneficial for me to take this particular node. And if this delta is maximum, so this is the maximum beneficial node. So let's say this is the maximum beneficial node. If I am gonna take it, I need this much value, but currently I am having some of the all these values, but also have this delta calculated for this particular node. So basically, if I have the sum of all values, so if I add this delta into this sum of w plus dp1 minus dp0, don't you think this dp0th value is already included in this sum? So if this dp0th value is already included in this sum, it's gonna cancel out with this value, and I'm only left with this value plus some of other dp0th values as well. But for this particular node, I only have this much computed, and this is what I need. So that's how I'm gonna sum up my delta maximum deltas, and will add it up to the 0th sum. And for a dp1th value, I know I can only take k minus 1 deltas, and for dp0th value I can take k deltas. So for this particular node, I can compute all of these values and will update dp of 0th and dp of 1. And once I'll go up, I know that dp 0th and dp 1th values of the below childs are already computed, and we can use all of the computed values of this level to compute the value of this particular parent. And my final answer would be dp of, I could say, root 0, that max answer in subtree of root by not taking the parent edge, because there isn't any edge on parent and हमें उसको लेने की कोई need ही नहीं है. So if we see the solution for this question, straightforward, we are going to create an adjacency of type vector pair, resize kara, just initialize the tree by uvw values like this, that adjacency of u has this particular node connected to it with this weight. Cool. So this is our dp array initialized with 0. So this is a function dfs. We have initially sum calculated, sorry, sum initialized with 0, delta for every node. So for any leaf node, we know the answer will be 0 0 for both the values, because there won't be any subtree below this and there won't be any edges. So in that case, the maximum answer I can get from any leaf node is 0. That's why we had initialized this array from 0. And for any leaf node, it won't have any child, so no values initialized in this delta, and so none of these loops will run, and all of the values will left unchanged as it is to 0 itself. So here we are gonna iterate on all childs of any the particular node, and if the child is equal to parent, so this is the ideal DFS condition check, that we don't call the DFS again on the parent to avoid infinite loops. So we are gonna call DFS on the child, and once the values of all the childs are calculated through these DFS, we can compute the answer for any our R node by commuting the delta, which is weight plus child 1th value minus child 0th value that we talked about, and sum में हम सिर्फ 0th value को plus कर लेंगे. Similar, we'll put this delta into a vector. We'll sort the vector in decreasing order, and we'll compute the dp of child 0 where parent edge is not included. So we have k edges, तो k edges उठा लो. K edges उठाने के लिए we can run a loop from minimum k of size of delta, because in some cases the number of nodes available is already less than k, so in that case we can take all of them. But if the delta is negative, so we'll try to avoid this edge, because this can be included in the subtree of the child node also, and child node is exceeding the value k. So for that we should break out from this loop whenever our delta value is negative. So that's how we are gonna compute the option 1 answer, which is for dp child 0. So it will be sum plus operation 1. Operation 1 is nothing but the sum of all positive deltas. Similarly for dp child 1, we are gonna commute this delta by only taking k minus 1 max values. So this is the loop for that, and that's how we are gonna calculate our 1th value. And this is the simple code for this dfs function. We'll call this dfs from root by considering -1 as the default parent, and we'll return dp0 of 0. So this is nothing but 0th value of root, 0th value of. So this was the solution for problem D, and my idea and intuition behind solving this problem. And this is the ideal DP on trees question, or I can say the template code, which is generally being used in most of the DP on trees problem. The main thing is this logical part, that how are you gonna commute or store your answers and use them wisely. So thank you so much for joining, and I'll sharing the link of all the codes. And for the problem A and B, I will share the code links, so you can have a look. If you have any doubt, do let me know. Thank you so much for joining.